So in this video, we're going to be looking at completing the square and also be looking at the standard form of quadratic functions. So in our previous video, we looked at the vertex form, which is represented by uh, vertex which is represented by a times x minus p squared plus q, and our vertex, which is given directly from, which can be derived from our vertex form, would be p and q. For our p, it would be the opposite sign of whatever we are given. Now, the same way our standard form gives us our y-intercept outright, which is our c value. For example, if we're given our standard form x squared plus 4x plus 3, y is equal to, our y-intercept for this function would be 3. So we're given outright uh, right off the bat from our standard form, and it is the last term. Our last term of our standard function is a y-intercept. And if we want to find our vertex from our standard form, we would use the formula negative b over 2a, which is the shortcut. The other way we're going to be talking about today is called completing the square. Completing the square. So completing the square is another way of how we go from standard form to vertex form. So let's take our example that we have here, which is y is equal to x squared plus 4x plus 3. And if I wanted to find the vertex of this using the completing the square method, or convert this into my vertex form, I would follow a few steps. My first step to do completing the square is I have to make sure I don't have any, my coefficient of my x squared is always 1. And in this case, it is. So that's good. The next thing we would do is group our terms. So in completing the square, I like to group my first two terms together, which have the value of x in them, and I would like to leave my constant outside my brackets. The next thing I would do is use my formula b over 2 squared to try and find my c value, or my last term here. And in this case, my b is 4, so I have 4 divided by 2 squared, which is equal to c. So I have 2 squared, because 4 divided by 2 is 2, is equal to c, so c is equal to 4. Now I know my third term, which is 4, so I can put in my third term. And now whatever I add to my function, I have to also take it out. So I take out my negative 4. So now I have changed nothing except I've changed no value of the function. All I have done is added a 4 and subtracted the 4 away, and this is going to help me factor and convert to vertex form. Now I know that my x squared plus 4x plus 4 is a perfect square, which is also what we need in our vertex form, because we have here, as you can see, x minus p squared, and for our term to be squared, we need something that's, of course, can be transformed into a perfect square. In this case, it can, because we can have x plus 2 squared. So essentially what we're doing with completing the square, as the name suggests, square, we are adding a term to our function to make it a perfect square. Now I have minus 4 and plus 3, which gives me negative 1. And now I have converted successfully my function from standard form to vertex form. Now my vertex, I know that my vertex now is negative 2 and negative 1. This is my y coordinate. And my opposite of my p is my x coordinate. So there we go, that's my vertex. Now let's do another question, a little bit more complicated. Y is equal to 4x squared plus 8x plus 9. Now pause the video and try to complete the square on your own, and come back. All right. So the first thing we want to do is take out our 4 from our function because we cannot have a coefficient of 4 in our standard function when we want to convert it to vertex form. Our coefficient, as I said before, of x squared always has to be the number 1. It always has to be 1. So here I can take out my 4. And there's an exception for completing square. I don't have to take away my 4 from my 9. That's an exception you have to make for completing the square. So when I take out my 4, I have x squared plus my 2x plus my 9. And of course, I can make an exception and I don't have to factor that out. Now to find my third term, I can use the formula b over 2 squared. My b is 2. So I have 2 over 2 squared, which will give me 1 squared, which is also just 1. So I know my c value, my third value is 1. Third term is rather. So I have x squared plus 2x plus 1 plus 9. Now I have to take out my 1, whatever I put in, I have to take out. So I can have to take out my 1. So in this case, I've taken out my 1 and I'm at plus 9. Now, when you have a coefficient and you're taking out a number for first two terms, you have to multiply your coefficient with the number you're taking out. So in this case, I'm taking out a minus 1, so I have to times it with 4. And what that will look like is a positive 9 and a negative 4, because 4 times 4 is negative 4. So again, when I'm taking out a term from my function, I have to times it with the coefficient that I have before I can bring it to my last term, which would be 9 in this case. So I have 4 times x plus 1 squared plus 5, and now I know my vertex. The opposite of my p is negative 1, and my y value is 5. So that was completing the square.